Okay, thank you very much, David. Much appreciated. So my name is Paul Joyce. As David said, I'm co-founder of Gecko Board. We're based over in Shoreditch, a small team. A little bit of background on me. My kind of previous to doing Gecko Board and various attempts at failed startups before that, I was working around here, working for mainly investment banks. Also, the regulator was the FSA at the time. And I was designing and building data warehouses. So pulling in data from different parts of the business, structuring that, putting it into dimensionally model it. Then somebody would come along with maybe an enterprise tool like Business Objects or Cognos or ClickView, something like that, and start creating reports. And that would be analysts poring over those reports. They would then spit it out into a PDF or an Excel spreadsheet or maybe even a PowerPoint presentation, and then email it throughout the business, and nobody would look at it. And so there was this problem. We were great at collecting data, great at storing and structuring data, great at even the analysis piece, but actually that last mile, that communicating data for human beings in a way that they could understand wasn't being adequately solved. So I started with the idea back in March of 2010 of actually how do we go about creating a tool that allows people to communicate data in a way that's understandable for human beings. And the great thing about this is that if you can take data and you can disseminate it throughout your organization, it doesn't just mean that data gets into more people's hands more easily. It actually allows cultural transformation because people are in touch with the data that makes sense to them. So we created the tool. The vast majority of our customers put them up on big screens, maybe smaller than this whole thing, although we have some that are even bigger out in warehouses in the US. They put it up on big screens so everyone can see in the department and the organization what is important, how are we moving with our data at this point in time. We also have an iOS app. We have over 2,500 paying, it's just 2,800 now paying customers. We have a lot of small to medium-sized businesses. That's who it was designed for originally. The small businesses that have a lot of SaaS products that want to be able to visualize data in a way that's very intuitive, pull metrics in from, say, Google Analytics or Salesforce or Zendesk or something like that. But it's also increasingly being used by larger companies, Dow Jones, BBC, and things like that. So, we're a small team, but growing fast. What I'm talking to you today about is how our brains process data. Some of you may know a lot about this already, but this was a journey that we went on, and it's been very informative and helped us to shape our product in a very real sense. So let's start with Tufte. I suppose you all know this guy. Visual displays with data are something that human beings are designed to absorb, okay? And it is oftentimes the best way of absorbing data. It really is. And there's many reasons for that, but which we'll go into. But it's the combination of our eyes and our visual cortex that's evolved over many thousands of years to get us to where we are, and there's certainly evolutionary reasons for that. But before we go too much into kind of like data visualization and where kind of we are kind of concentrating on, I want to describe like the spectrum of data visualization. On one end, we've got maybe data as art. I know I was sat down the back earlier on, maybe half the screen you can't see because of people's heads, but we've got this kind of thing that's really beautiful to look at. It's art generated from data, and it's a wonderful thing, and I love it. I really love it. Big David McCandless fan, love infographics, all that kind of thing. Further down, like the spectrum towards like complexity or abstractness, if you like, we've got infographics that were all the rage, and I know the infogram guys are here today, maybe talking about some of that later on. But these things are fantastic, great ways of taking you on a journey with data. Say, opening different parts of your brain to interpreting data in a way that you hadn't anticipated before, and they require you to sit down and actually grok and understand and read that. Okay. The area that we're interested in is like glanceability, like really like simple. I look at something, I understand it. Either through some preconditioning or the way that the data is presented. It's about you're driving down the road on the motorway, you're doing 70 miles an hour. You want to see if there's an engine management light on, or you're about to run out of fuel, or you're sticking within the speed limit. And it's about looking down and looking straight back up again and having some sort of processing done without any real cognitive thought, no cognitive overhead to that. So when we start exploring this, we see that our brain is really very well geared, wired for that sort of glanceability if we respect the way we process it. So I've got a little fun game, hoping it's going to work. The idea here is to find a red circle in a sea of blue circles. Now, if anyone's red-blue colorblind, this isn't going to work for you, but no, seriously, but there's the vast majority of the population that should be fine. So here we go. Fingers crossed. No. Oops. Bear with me a second. Here we go. All right. So as you see, you can see whether that's like very, very quickly, see whether a red circle is there or not. It doesn't matter if we reduce the exposure time, so it's getting quicker and quicker each time, or increase the number of points on there, right? You've actually managed to very, very quickly, almost precognitively, understand whether that red circle was there or not. And there are a few reasons for that. What's actually happening here is that the stimulus is hitting the back of your eye, the retina. It's then going into the primary visual cortex, into your brain, into the thalamus first, into the primary visual cortex, and into the association cortex after that. And what's actually happening is that each stage throughout that process, filters are being applied, and your brain is saying, can I do anything with this? And certain attributes are sticking out, some more than others. Now, some of the things that are important are, does it stick out? So as you can see here, the red dot obviously sticks out because it's unique in that sea of blue. The other side of it is like, the decision that your brain makes, am I going to kind of process this further? Is it important, right? So there's two sides of it. Is it salient? Does it stick out? And is it pertinent? Is it important? And then so you can use that as a way of like saying, well, if it is important or if it is salient, then we'll move on to the next step and the next step and the next step. And in each step, this gets magnified. You're able to distinguish between shades of gray and then different types of like contrast, shape, curves, all those kind of things. And then it goes into your conscious processing. But that very early stage, where you've seen, almost instinctively or intuitively whether that red circle is there or not, has been called pre-attentive processing. And this is essentially, like, all information around you is pre-attentively processed. And a very limited set of visual properties are detected rapidly. And once they're detected, like by the very low-level visual system, they'll then, if they are detected, that's called pre-attentive processing. And we know that attention plays a really critical role in this. So if you know that you're looking for the red dot, then you're conditioned to do that. But the way people used to look at it was that pre-attentive tasks were something that was done in the visual cortex. It required no conscious thought. Thinking has moved on since then. And actually, what we now know is it takes about 200 milliseconds for your eye to initiate a movement, okay? And yet, some of those red dot slides that I was showing you earlier on were shown up there for less than 200 milliseconds, and yet you were still able to process that. So our eyes are able to kind of process, if you're able to perform tasks on a multi-element display, and our eyes are able to see like 625 elements in a square inch. If you're able to process tasks in less than 200 to 250 milliseconds, we call that pre-attentive, and that's how we can define it. So we know that color, from the previous example, color works as a way of pre-attentively like showing you differences. We're going to find the red circle again, part 2, Revenge of the Red Circle, and let's see if we can get this to work. Now, this is slightly different. You're looking for a red circle in a sea of red squares, okay? So the difference here is not color, the difference here is shape. So you're looking for the circle in a sea of red squares. So let's see if this works. Okay, so this is what you're looking for. So we'll start slow and quickly move on. More and more elements, shorter exposure time. So I don't know how this kind of looks on this big screen, but I certainly know if you go to this kind of video linked through to on YouTube, you can try it out for yourself. But you get it right pretty much all the time. Again, unless you're kind of colorblind, which is obviously a different thing. So we know that shape plays an important part. It's a pre-attentively processed attribute. We know that color is another pre-attentive attribute. So it might follow then that if you were to take a combination of shape and color, you might be able to that could be pre-attentive in and of itself. So the last little test, find the red circle, part 3. This time it's personal. Here we go. So we're looking again for a red circle in a sea of red squares and blue dots, okay? So let's try this. Red circle. There it is. Now this is an entirely different experience. You're not going to pre-attentively process that. There are 2 attributes at play here. So your brain is now working in a fundamentally different way. You're not, instead of having this massively parallel system where you can very quickly see whether that dot is there or not based on an attribute, you've got what's called here a conjunction. Just get a drink. And so instead of parallel processing, you're having to look through it in serial. So it's almost impossible to find that red dot in there. So we know that pre-attentive attributes by themselves can be very useful. You throw too many at people, and they're not going to be pre-attentively processed anymore. So Stephen Few lists a bunch of pre-attentive attributes here. So there's all sorts of different ones. And they can be used for different things. If you're displaying quantitative data, there's only really 2 that are interesting to you. There's the 2D position. So you imagine these are dots on a scatter graph. You're able to very quickly see where they are. And then, of course, line length. So you're able to compare different lengths of lines very, very quickly. Color intensity, right, this one down here, which half you won't be able to see. Color intensity, you could say you could use that to display quantitative information. Okay, you could say like you'll have a sliding scale of grays, like from 0 to 100, and the intensity actually, it designates that. But really, it'll give you a rough approximation, but it won't give you any sort of accuracy. So color intensity is not much good for that. 2D size. You see that a lot in charts and presentations and all that kind of thing. It's great for saying that there is a difference, but it's crap, as far as we're concerned as human beings, at saying what the magnitude of that difference is. That's one of the many reasons that pie charts are fairly unsuitable way of representing data. And actually, I've got a great example of that. Not only just using like 2D space, but let's see if you're really devious and you want to completely ignore the rules of pre-attentive process and you want to do something nasty. You can use like pie charts, like 3D pie charts. Okay, I'm aware some of you have probably seen this. It was on the Guardian blog, I think, a few years ago. But it was, this is, I think, 2008, Steve Jobs presenting the keynote saying US smartphone market share. And the way he's like structured this pie chart, it gives a really good indication of a couple of the things I'm trying to demonstrate here. First of all, measuring volume on a 2D space, even though it's displayed in 3D, it's a bit funny. So intuitively, I'm not sure if it comes out all that well. This is purple here. This is like a magenta kind of pinky thing, green turquoise. It's very easy to see that the turquoise shape is the biggest there. What about the second biggest, right? Again, if you're not looking at this in a cynical mind and somebody's just showing it to you, I think most people would say, well, actually, the green is the second biggest area here, followed probably by the purple and then the orange and the red. Okay, so let's see what happens when we add the percentages on there. We can see that actually green isn't. What they've done is that they're using that trick of the mind. They've brought the pie chart closer to you. This looks like a bigger area, so our brains are going, okay, that's bigger. This has been, for some reason, shunted to the back. It makes it look a little bit smaller. Okay, so then we say, all right, let's take 3D out of the equation. What does it look like if we flatten it down? And again, we can see like the positioning of these are slightly wrong, but it's a little bit better. But the magnitude of the difference isn't really been communicated here because we can't, like the 2D shape is very hard. But how could we get that same data set and have a look at how we can kind of process it a little bit more pre-attentively or a little bit more intuitively compared to how our brains work. And this is going to be a lot more boring than Steve Jobs' slide, but hopefully a lot more informative. And that's just a simple bar chart. Very simply ordered by size. So you can see the magnitude of the difference very, very easily just by comparing the lengths of these. So again, this is one way of looking at it, and this is another. And if we want to be honest and communicative and allow people to judge magnitude and things like that, just keep these kind of things in mind. So that pre-attentive processing, the combination of using your retina and your visual cortex to very quickly hack into the conscious area of your brain, has to be married with how our memory works. And so there are three components to our memory. This is grossly oversimplified. There's like the iconic part of our memory, which is like a buffer, if you like. It takes what you get from the retina and holds that there for very short amount of time before shunting it onto short-term memory. Short-term memory is that's where the processing happens. Short-term memory takes information from the eyes and it takes information from your long-term memory, like these kind of vast arrays of like old information, combines it together in this working area, and then that's where it's processed. So that's if we're talking about like optimizing for interpretation, we need to optimize for short-term memory, particularly if you're looking at very quickly glanceable stuff. So optimizing for short-term memory. The great thing about this is that there are some rules around it, okay? So the main rule, it's probably best to demonstrate it. Imagine we have a fictional bakery shop, and we want to have a look at our sales. Now, for some reason, I put 2014 up there. We've got December. Forget it. Maybe it's last year's sales. Okay. So we have a couple of things here. We have cakes in blue and muffins in red, and we can very quickly, we can keep all of this in our head. We know that these are cakes and these are muffins, and we're looking at it and it's fine, okay? We don't have to keep going back and forth to the legend. So what happens if we add another thing in here? So now we have croissants. They're down there. So now we have three components on here. We can still interpret that. We don't need to we can still remember that's cakes. That's cakes, that's muffins, that's croissants. All right, that's good. Now, if we start layering on more things on here, we get to a point pretty quickly, about now, I would say, where actually keeping all of what does each color relate to? What's cakes? What's muffins? What have we got here? Flapjacks. You're suddenly starting to go back and forth between the two, between the legend and the chart. And you've now stopped using your short-term memory optimally. Let's add some more in. What have we got? We've got white rolls and brown rolls, whatever. Yeah. So again, like the idea here is if we're actually trying to use our biology to help us here, don't put too much information on there. Let's say 3 to 7 chunks of information is what our short-term memory can process at any one time. That's stimulus from our eyes and stuff from our long-term memory. Ideally, less than 5, and more research is saying like probably 5 is more like the upper bounds. So again, if we're looking at using our short-term memory, these are the kind of things to keep in mind. And this is, again, on the glanceability side. It doesn't say anything about infographics or anything like that. But OK. So I'm just going to do a quick recap of what we talked about. We're almost at the end here. First things first, where in the data visualization spectrum are you? Remember that. If you want things to be interpreted at a glance, then there are certain things you need to do and certain things you need to kind of be aware of. And that's really what we concentrate on today. So if it's glanceability, we need to design for how we process informations as a species. And the two main things there, pre-attentive processing, which includes decide what you want to highlight, and choosing the right attributes, whether that's color, size, shape, two-dimensional space, all of those kind of things. Use the right attribute to be properly pre-attentive and don't throw too many at it. And the second side of it is optimize for short-term memory. So that's 3 to 7 chunks of information, ideally less than 5. So that's it for today. Hope you enjoyed it. Hope maybe you learned something. And any questions, ask me afterwards.